Hello, everybody. Welcome to SETI Live. I'm your host, Beth Johnson, Communication Specialist here at the SETI Institute. Thank you to our viewers from around the world for joining us, and please let us know where you are watching from in the comments. As research teams around the world prepare for the launch of two separate missions to our so-called sister planet Venus, other scientists are spending their time looking through the data that we've already collected from previous missions. Joining me today is Professor Robert Herrick from the University of Alaska Fairbanks, who is the co-author on a new paper published in Science last month that details possible evidence of recent volcanism on Venus found using Magellan images from the 1990s. So thank you for being here today, Dr. Herrick.
Thanks for having me, and just for viewers in the background, I had a problem with my desktop computer, so I switched to my laptop right as we went on air. So I think we figured out the technical glitches, but anyway, sorry about that.
No worries. We're glad you're here. So thank you so much for being here to do this. Let's start with the beginning. What did we know before this paper came out? What was our knowledge of volcanism on Venus? What did we know for certain? What did we think we knew?
Okay, what we knew is that Venus overall is a young planet. It is, in terms of using kind of the distribution of impact craters to try and estimate the age of the surface, we knew that it was much younger than, say, Mars' surface overall, reasonably comparable to Earth's, although there is some debate as to overall whether it's more kind of comparable to Earth's continents in terms of ages or as young as Earth's ocean basins. And then we had a lot of circumstantial evidence that there were places where there were unweathered, so relatively young basaltic lava flows on the surface, and so that we had a lot of circumstantial evidence that Venus was volcanically active. But in a planetary sense, volcanically active could mean that the next eruption is going to come in a few years or a few decades or 10,000 years. All right, so just for comparison, Mars also has some lava flows that are geologically young, but we haven't seen anything happen on the surface there in the last 50 years that we have observed it. And nobody's expecting, it could be 100,000 years before something erupts on Mars. So that's what we knew before this discovery, and there had been a lot of speculation as to really how comparable in volcanic activity Earth and Venus were.
All right, I'm going to welcome in some people, and then I'm going to ask you some more questions. So welcome in to people who are watching from, let's see, we have Jersey, Central Jersey, so okay. The UK, Canada, the Pacific Northwest, India, welcome in, Denmark, South Africa, let's see, more from Canada, Nova Scotia, Canada. Welcome. I have family in Nova Scotia, so that's exciting. Local here in San Jose, Wisconsin, Virginia, Washington, D.C., Illinois, Massachusetts, Texas, more from Canada, Oklahoma, Portugal, Arizona, oh, wow, Sudan. Oh my gosh, so many places. So literally watching from all over the world. Thank you, everybody, for being here. My guest today is Dr. Robert Herrick, who is the co-author on a paper about active volcanism on Venus. So we knew there's volcanoes. We didn't suspect there was anything, recently active, but possibly geologically recent. What was the impetus for this particular project? Because I love the story of how you kind of got to doing this. So can you share that with our audience?
Well, sure. Just to the, maybe answer a question that wasn't asked, which is why this was done with 30-year-old data. Why wasn't it done before, right? When the data first came out, this was back, the Magellan spacecraft launched before the Berlin Wall fell, right? And so at the time, it took, about 10 or 15 seconds to take your average computer and put up a single frame of data. And so it really wasn't until the last decade or so where it was the hardware and software made it relatively easy to do this kind of search. For me, as I think you mentioned, I'm involved with a couple of future missions going to NASA. And at the time I started the search, they were still in sort of finalists for selection. And we had written into the mission plans that we were going to search for, look for changes with time and look for, ongoing volcanic activity. And I thought, well, it'll enhance our chances of selection if we could actually show that something changed during the Magellan mission. And so that was how I started. Fortunately, the missions got selected, even though I had not finished my search by the time that those selections occurred. But and then sort of while I was shortly after I started, sort of COVID hit, and so I had a lot of, like many people, I had many Zoom meetings that I was expected to attend. Not all of them I was required to be fully attentive the whole time. So there was some time there where I was able to kind of scroll through. Basically, what I was doing was scrolling back and forth between images taken at different times, going around the planet looking for something. And so this is something that's, it's time consuming, but perhaps doesn't involve your whole brain. So it's something I could, I wouldn't say all of the search took place during Zoom meetings, but there were parts of it that did. So it helped a little bit to have some that, we could say it was somewhat COVID aided, I'd say.
It's a very interesting research technique, simply because this is old school research, right? We've, if you know anything about how astronomy was done before computers, really, it's you had astronomical plates with images, and you basically lined them up and compared them, and point by point, okay, that has moved, that has not moved, and it was very tedious. And so much of what we hear these days is sort of, we've made an algorithm, we've done a thing, now the computer can do it. And here you are going back to sort of this, lay them out side by side, compare them, and how do they differ? So using this old school technique, which is fantastic, on 30-year-old data, what did you find?
So yeah, and let me address, let me show you what I found, and I will address a question that you implied, which is, why didn't we have some automated process, right? So I have like 3 slides here. And so what you're looking at here is, this first one is just a global map showing the data as it was collected by the Magellan mission. And so the Magellan mission, the way it collected data, it passed over it during a 24-month period between 1990 and 92. It passed over every point on the surface of Venus 3 times. And so once every 8 months. While it was doing that, while it was doing this image, the spacecraft started to deteriorate. And so each 8-month data collection sequence, it collected less of the planet than the previous time around. And so the gray background is the data coverage that was obtained in the first 8 months. Then what you see in the red is the second 8 months, and then the green is the third 8 months, and the yellow just shows where data was collected in both the second and third set of 8 months. All right. One of the problems though, is that the mission was not actually designed to look for changes with time. And so each time it passed over each one of these imaging cycles, it was looking at the surface from a different perspective. And so the second time around, it was looking at the in a completely opposite direction of the first time. And then the third time around, it went back to looking in the same direction as the first time, but with a different look angle. And so because of that, particularly from the first and second cycles, the difference in the viewing is so different that there's no way to really automate a search like you might be able to do now with astronomy plates, where you can sort of you can automate that, and what's changed, a streak going across that tells you something has changed relative to the background. So let me go on to so what I did was, I had kind of a list of the 25 most likely places where I thought something might have changed between over these 8-month periods. And as I said, working with the first and third cycles, where you're at least looking in the same general direction, is easier. So I started looking in my list at those places, and then finally kind of bit the bullet and started working with this opposite look data between the first and second cycle. And that's when I hit pay dirt in this area that's sort of the yellow box there. And so if you'll go to the next slide here, I can sort of start zooming in on this. This particular area is, if you were to have placed bets before I started the search as to where the most likely place on the planet to find active volcanism would be, it would be in this area. This area has the tallest volcano on the planet, which is Mont Mons. It's about 9 kilometers high. This area has, there's also a couple of other gigantic volcanoes nearby. It's at the intersection of a couple of major rifts. It has a geophysical signature that indicates there's a big mantle plume underneath it, just like in Hawaii or Iceland. And it's one of these areas where we had a signature in the data set known as the radar emissivity that indicated that there were unweathered basalts on the very top of Mont Mons. And so this is, like I said, the most likely place. And so in the image on the left, the small black box is the area that we're going to zoom in on the top of Mont Mons. And what you're seeing here, the colors of the topography, where the reds are high and the blues are low, and then the background is the SAR imaging, and you can see some of the flows that are going down. This volcanic complex covers a few thousand kilometers across, so it's quite large. And then on the right, we're now zooming into the summit area of Mont Mons. And so and what you see is that there's the black rectangle we're going to go to in the next slide. But in this slide, you can see that we're looking at kind of a volcanic complex that's just off the north summit of Mont Mons. And if you go to the next slide, this is sort of the big discovery slide, right? So now you're looking at an area that's I guess about 20 kilometers or 10, 15 miles across. And the images overall, these images look somewhat different simply because of the viewing geometry. But the and so just kind of give you a little bit of a feel. You can kind of, for those that are not familiar with looking at radar images, you can kind of think as if you're flying along on a northbound airplane, looking down at the ground out the window. And so on the left image, the viewpoint would be as if the sun is off to the left side of the plane and you were looking down at the ground out the left window. And then on the right, it's more like the sun is off to the right side of the plane, so it's off to the east, and you're looking out the right window. And so that explains a lot of, so the same features then look like they have different sets of shadows and different a little bit of shifting back and forth due to the parallax you get with elevation. But so there's a lot of stuff that hasn't changed but looks different simply because of the viewing geometry. But the one thing that has changed that we can explain because of the viewing geometry is the thing shown with the big arrow that says expanded vent. And so you can see on the left that it looks like there's a large circular vent that looks kind of deep and just off to its northeast are a couple of small pits. And then on the right side, you see now it looks like it's kind of a kidney bean shape, and it's dark in the center. And I would say that probably there are some active lavas that have partially, that the vent has expanded and been partially filled. And so that's basically the big discovery. And so that's so we found a change over an 8-month period in 1991.
That is seriously amazing to me. I'm gonna welcome in some more people because we've had some more say where they're from. We have the state of Georgia, Northern Highlands of Scotland, Berlin, Australia, wow, Nicaragua, Minnesota, Louisiana. Hello, Ron. New Zealand, South Wales. So again, just even more spread out. Thank you, everybody, for coming in and watching. If you have questions for Dr. Herrick, please let us know in the comments. We are going to continue this. All right, so you have found a change. It looks like it seems pretty reasonable that this is an actual change and not some sort of strange photographic artifact. From what I saw on Twitter, people went and started trying to analyze the images on their own and agreed, no, this is definitely something. What is, based on what we know about Venus and the fact that this is not a world with active plate tectonics, what is the mechanism? What is driving the magma generation for this particular planet that could maybe have driven this expanded vent incident?
Okay. Well, let's see if I can kind of dissect that a little bit. Let me start out with just a basic thing, that Venus is almost identical in size to the Earth, and simply from and so it should have started with a similar amount of radioactive elements and formed at about the same time. And just from the general idea that really what's going on, plate tectonics, volcanism, all of that is really just a planet cooling off, right? And so in general terms, we expect that Venus and Earth should be similar in terms of their overall level of volcanic and tectonic activity. And when we look at Venus, it has plenty of evidence of volcanic and tectonic activity, but currently that tectonic activity is not organized into plate tectonics like it is on Earth. And so then there's been a whole bunch of different ideas to try and figure out what's going on now and in the past that can result in the current display. Okay, and so there's a couple of flavors of ideas. One is that one way you can do it is to wildly fluctuate the level of volcanic and tectonic activity, and you could have currently Venus is what would be known as stagnant lid, or it doesn't have plate tectonics. It's kind of a fixed lid, and it's not very active right now, but at some point in the past it was way more active and had a very rapid turnover of the surface, and therefore averaged over time, you cycle through that, and averaged over time you get kind of the average amount, similar amounts of heat release. There are other ideas, other flavors that basically say no, really there's just something different going on. Venus doesn't change that much, fluctuate that much with time, but there's some other mechanism going on. And so some of these ideas then would kind of a boundary condition for sorting through some of these ideas is understanding the current rate of geologic activity. Some of these ideas have it currently far less than Earth. Some of them have levels of volcanism comparable or maybe even more than Earth at the present time. And so having this current discovery kind of it rules out some of the more extreme cases, but with these upcoming missions, we really want to nail down what I think is sort of a boundary condition on these scenarios, which is what's going on, where is it going on currently, how much activity is going on, and what's the nature of it. And let me just throw in as another exciting teaser that some of these past scenarios have Venus being much more like Earth up until a billion years ago and having plate tectonics. And if you had plate tectonics, most people think that would have had to have involved some element of liquid water on the surface. In other words, a habitable planet up until a billion years ago. So I think I overkilled on the answer to your question, but that's the basic gist of it. So.
In looking at these images and seeing the change, aside from the possibility that this vent has expanded because there's been a new lava flow, is there another option for the mechanic behind that change?
Okay, so I feel confident in saying that the vent has changed. With the existing data, we don't quite have enough data to do something that involves, say, volumetrically comparing the before and after topography. And so we cannot fully rule out the possibility that what happened is that the vent, for some reason, there was some sort of spontaneous collapse, and the change from over 8 months just involves sort of tumbling landslide or something. The structure collapsed and made a different structure, and there was no accompanying volcanism with that. However, there is no example of a terrestrial volcano, a volcano on Earth experiencing a multi-kilometer change in a caldera or vent without a lava flow coming somewhere, without volcanism occurring somewhere. There are examples of, in fact, in the paper we drew an analog to the 2018 Kilauea eruption where there was a caldera that collapsed, but the lava actually came out. It was the caldera collapsed because the magma chamber underneath drained, but the lava itself came out of vent that was located a couple of kilometers away. So there are examples where one thing collapses, but the lava flow is somewhere nearby. But there are no examples of something just collapsing on top of a volcano and nothing else happening. So, and so in the paper, and also I didn't mention it, but there's also an area where there's potentially some new lava flows off to the northeast, and it's where it's downhill from the vent, and so if there is new lava flows, that's probably where they would be, and there might be a change, but we just don't have enough data to definitively say those are new lava flows. So those are all the qualifiers. So something definitely changed. There's I suppose what I would say a very minute possibility that it did not require volcanism,
Oh no. I think we've lost you. Robbie, are you still there?
Are you there? I lost you for a second.
Yeah, there you are. You're back. Okay.
Okay. Uh-oh.
You seem okay now. All right.
Uh-oh.
All or
right.
Maybe not.
Cycling a bit here. Okay. Are you there?
Yeah. No, you were definitely cycling a little here.
Okay.
All right.
Great. I think we're back. All right.
Yeah. So on sort of that note of what we need to find out, Nikki asks, which of the future Venus missions would be most helpful in clarifying the picture of Venusian volcanism? And bonus points for using the word Venusian.
Okay, can you hear me? I can see the question, so can you hear me?
We can hear you.
Okay, good. All right, so which of the future Venus missions would be most helpful in clarifying the picture of Venus volcanism? So there are two. The Da Vinci mission, which has a probe, is mostly concerned with understanding past conditions on Venus, and mostly about understanding the past atmosphere on Venus. And so it does not have a great deal to do with learning too much about current levels of volcanic activity. Two orbital missions that are coming up, which are Veritas and Envision, both have synthetic aperture radars that are higher resolution than Magellan, and will have campaigns to search for changes over, and obviously this will be one target, but there will be a whole list of targets. And so both of those missions will be looking for changes both from over the 4-decade time span since Magellan, and also going forward during the missions themselves. So, and then also the Veritas and Envision missions will have an infrared camera on them that will be able to look for thermal anomalies associated with an erupting volcano as well, and hopefully and potentially see new volcanism from that as well. So those are the two that I'm involved with. There are plans for an Indian mission that would have a SAR that will also be able to do that, and then and I think the Chinese also have their ideas for a mission in the books as well. I think the Indian mission is a little bit farther along than the Chinese. I think the Chinese one is still mostly on paper, but I think the Indian one they're hoping to launch in the next couple of years. Yeah, so multiple missions coming up that will be able to look for changes with time.
Fantastic. I'm going to throw this last question up here because your connection is starting to show signs of wear, and I know we're also at our half hour anyway. So, but this is from my friend, and I have to put it up for her. Are you in need of postdocs to review the rest of the footage?
Well, so I actually have I took on a postdoc towards the end of last year, and she also happens to be on the science team for the Envision mission. So right now I am not in the need of another postdoc, but that might change in the next handful of months. But certainly there are people involved with both of those missions that have been looking. There are postdoc opportunities from the scientists that are involved with all three of the upcoming NASA involved missions. So, and you can contact science team members directly, or they post offers as well. So, and I think I've gotten back to I don't know what the problem was, but I think I'm back fully online now. So.
Fantastic. All right. Well, we have reached our half an hour, and I don't want to take up too much more of your time. So thank you so much for joining us, talking about this. I suppose if we were to leave it on one note, what's your hope for the future here? What are you looking forward to? What's coming up?
Well, of course, you may be aware that there's some issues with Veritas being on a kind of an indefinite delay. For the purpose of looking for active understanding current geologic activity, we'd like Veritas and Envision to, maximize the amount of time that they span, and preferably, so we'd like to claw back some of the launch delay on Veritas and have Veritas and Envision be a sequence that spans a long amount of time. And I, for me though, it's just going to be super cool that when these missions are going, we're going to see new volcanic flows, and we'll have the resolution to where they won't be, a few pixels of grainy images across. It'll be more like, it'll be closer to the idea that you're flying over an erupting volcano on Iceland or Hawaii, and you can see the details of the flows, and you'll be able to see how they've changed over, a few month time frame, and what's new and what's different. And it's going to be super cool. That's what we know now, right? They're going to see changes with time, and it's not just going to be like a sand dune changing. It's going to be something like a volcanic flow that is new on an Earth-sized planet. So
I'm looking forward to it, and because you brought it up, our friends at the Planetary Society, planetary.org, have a way to reach, if you're in the United States, to very easily reach your U.S. legislators, to send them a letter about keeping the Veritas mission running, so and getting it off that indefinite hold. So if you want to see that happen, you can head over to planetary.org and go to their Take Action page, and they'll have, it's basically the top link there. And we appreciate that they are on top of that. Thank you, Dr. Herrick, for being here today. Thank you to our audience for being here today. As a reminder, the SETI Institute is a 501c3 nonprofit organization. So all of your things like stars and subs and bits and super chats, they go straight into our education and outreach program like this. And if you prefer, you can go to SETI.org/give now and make a donation there and help us keep these programs running and help us keep having fabulous guests like Dr. Merrick and keep this going. So thank you again for being here. Thank you everybody for watching, and we will see you next week.
All right. My pleasure. Bye.